Hello, this is Mr. Doty, and I'm trying something new today. I'm showing you my face, scary as that is. Today, I want to talk to you a little bit about sectioning, and so I'm going to kind of do a lecture, if you will. Try something new. Hey, typically on the online classes, it seems like all you do is you kind of look at the book, you read a little bit, you look at a PowerPoint, might have some videos on how to do some things. But you really need to have some explanation on what I'm expecting, for you to turn in. So this is going to be a little video on how to do that, and hopefully it doesn't, turn into a 44-minute video. I don't think it will. I think I can do it pretty fast, but also cover what needs to be covered. So I'm not sure exactly where I'm going to be on the screen as far as me, but anyway, here I am, and we're going to go ahead and start. So today what I want to do is I want to talk to you about the third part in CAD 112, and this is Chapter 12, Sections, Breaks, Revolutions, and Conventional Breaks. And you're like, what the heck are those? Well, first of all, let's just talk about what we're going to do. So under here I have some instructions. Honestly, I don't have the right ones, so I need to fix those, but that's okay. Probably a good reason for me to have a video. Hey, you're always going to find things under teaching aids. Like I have a video on how to draw a countersink correctly, because some of your drawings, like this one right here, you have to do some counterbores, countersinks, things like that. And actually you have to do both on there. And then I also have the PowerPoint, which I've updated to the one that I'm going to go over right now. So I already have this open, but we'll come back to it in a minute. So as far as teaching aids, this video will show up down here, and you can watch it and hopefully learn something. Okay, so so we're in Chapter 12 under assignments. So I have the handout for the assignments here, and I've actually already got it pulled up. And so basically what you're going to be doing is a section basically is us being able to cut into a part and show you, well, actually, really what it's for. For one, it's to show you what it looks like on the inside. Number two is you are not supposed to dimension to hidden lines, period. Whether it's a center line for a hidden circle, a hole, or the hidden lines of a hole, or anything that is hidden, feature, line. If you can't see it directly, don't dimension to it, period. Now, let's back up. Why do we have sections? So that we can be able to dimension those things that we can't get to in any other way. Well, there you go. So if you look at this one is going to be a full section, and it's pretty simple. You're going to have your circular view over here or over on the right. It doesn't matter. The thing that I want you to get in your brain, and I don't know why some of the examples aren't set up this way, because your paper is set up in landscape mode. And you also have A, B, C, and D size, 4. You have 4 different sizes of paper in which to get this part, whatever it is, to fit. Now, I'm expecting you to have your dimension style set up correctly. I'm expecting you to have your text style set up correctly, and your multi-leaders, as well as your layers, and I expect you to use layers. Now, the other question would be is, oh, but I'm going to be using SolidWorks, or I'm going to be using Inventor. Well, then you better make your template, or make a template that looks like the ones that I've provided for AutoCAD, because it needs to be apples and apples. And if you're doing an Inventor, do not send me their AutoCAD drawing. Export it out. Because when you send me their version of a drawing file from Inventor, it comes up in AutoCAD and it looks really awful. So, just saying. So, anyway, Moving along, so whatever software you're using, hopefully, honestly, just use AutoCAD, really, because for this, now, I'm going to go over later on in a different video on how you can do some SolidWorks or Inventor, and that's fine. But I'm covering AutoCAD at this point in time as far as talking about what we're doing. And when you take CAD 200, you're going to do some sectioning similar to this, so it kind of reinforces it. I'm just going to kind of expand on it and show you some other stuff too. But anyway, in this video, we're just going to go over this. So this is a full section. Now, this one here, yes, it's sitting like this, but I want you, well, the reason I was talking about the paper size and the paper orientation is all of your pages are set up landscape, which means the long dimension is running X, horizontally. Well, that means that your view should be laid out horizontally. A section view or section drawing typically has a front and a side view, unless it's another variation where you're doing a broken out section or something else. But typically, when you're doing a section drawing, you're going to have the section view, and then you're going to have a front view, let's say. So the round view in this case, on this one, this would be turned sideways so that I would be able to put my section view over here to the side of it. And typically people do a front and a right side view because it's a right-handed world, but hey, if it's on the left-hand side, that's fine. Sometimes, actually, there's some later on where we're going to have to do something different. Now, this one, there isn't any reason why you can't, well, let me just say this. This right here, they want you to do a half section, which is just taking a quarter of it out. And you're like, what are you talking about? We'll get to it, promise. But I'm not exactly sure that you might have to do a rear. See, here's the whole thing. You're supposed to do the section view to help keep you from having to make extra views. I'm not sure how you're supposed to dimension this because you can't catch both lines to do a diameter, right? So other than showing the shape of that, I'm not sure that it's real helpful on the section. But this does show how this is all laid out. And since it's a symmetrical part, it's going to work that way. So, I mean, that is a, typically a round part, you can do a half section, which takes a fourth of the part away. This one is going to be, now, I don't like this one because similar option here is you've got this little undercut here, which they've got it dimensioned from here to here, but is that going to help the person who's making the part? No. They almost need a diameter to go off of so they can measure how far out, or if they're using a boring tool so that they can kind of go on the inside, and it's kind of like a it's not an exact straight cutter, it's kind of has an angle on it, or you can set it to where it goes in and goes into the side so that you can make that little indentation right there. Well, I don't know, I guess you could just put that distance right there. I'll have to talk to a machinist and say, hey, which is the better way to do this? So if I was trying to do the diameter of it, this half half section is not going to work very well for me, and I just assume do a full section. Hopefully, I think all of the dimensions on this one are okay. Anyway, if you run into any of these where the dimensions don't make sense, adjust it. Let me know so that we can look at it. I can look at it and you can tell me what you think. And, like I said, CAD solves problems. We'll figure it out. And I'll make a note. I'll put it on the assignment so that in the future, everybody can go, oh, yeah, we need to adjust that. Or I can put a note on the assignment sheet here. Okay, so moving along, I guess if you do, if we dimension this, just this distance right here, Then you can do a half section. So we'll try that and we'll go from there. I'll update the video if I need to. Okay, so this is an offset section, and even though it's drawn like this, your view is going to be like so, and then your section is going to be over here to the right of it, okay? And then this one is a revolved section. It's also going to be round like here, and then your view is going to be sitting over here. You'll notice that the cutting plane line, the arrows are facing away from the actual section view. And sure, some of this terminology I'm going to hit on here in a minute. You're probably like, why are you doing the assignments first? I'm just trying to show you what you have to do. All right, so now this one's going to have something special. This one, technically, you could do what we call an auxiliary view. And so we're not going to do a view down here at the bottom, okay? Because that would make it a portrait type. It just won't look right on the screen or on our sheets. So what I recommend that we do is we're going to do a removed view, if you will, and we're going to put a viewing plane line up here that is showing kind of like a camera view, so to speak, of where we're looking, and then we'll put our view, our round view, over here. So it's not going to be a projected view per se. It's going to be an alternate view. And so it's a little bit different. Now this one does a broken out section, and I've got some, we're going to go over that too. You don't have to break it down all the way to here. Really, you just need to come down a little bit and do your short break line over. Okay, now this critter right here is fun. I have an example that I will make sure is uploaded that gives you an idea of what it looks like. Again, please do it horizontally where you have a circular view and then a sectioned view. Okay, now this one you're going to do a couple of different things. This oval section right here, this ellipse, that is going to be I believe it's called a revolved section. Double check. I get my names mixed up sometimes. But basically what you do, it's like you took and cut it and flipped it right on an axis right there on the part. So, and there's a couple of different ways you can do it, with or without a break, and we'll talk about that a little bit more. But you're also going to have, basically you'll do a full section of it, and then on this front view here, you'll do your revolved section. So it's kind of a complicated or a complex, not complicated, but a complex design problem. And when you draw this, try to make a center line between the hub and the ring out here, and just do the best you can to get that S, kind of that little S curve there, and then you would offset it. And if you were drawing it in a 3D modeler, you would just find the center line as well, and then you'd have to make some planes, and so they're a little bit more complicated on that one. But you could do a oh, let's see, not a loft, but a I'll think of it in a minute. But anyway, you'd have a path and you'd follow it, and you'd have a shape, and there you go. I always forget that one. I can't remember what it's called, but I'll remind myself in a minute. I'm going to have an example of this as well. This is going to be on a different video because I want you to see how you can do a detail view at a different scale using viewports. I mentioned that in one of my other videos on setting up the template. That'll be located there. I may put it in a couple of different spots just so that you have it. All right, and this one's going to have, it's going to be sideways. It's just the way I had to put it on the sheet here. But it'll be horizontal, and you've got a right side view and a left side view, plus you're going to have these three sections here that you're going to put, somewhere over here. Try to make it organized and make it logical, and it makes sense, okay? Logical. That's what we're going to shoot for. All right, moving along. Now this one is what usually kicks people's butts. They don't have a clue. In the book, or at least it better be in the book, I'll double check, and if not, I'll find another option and show you how to do it. Maybe I need to do a video on how to do conventional breaks, but there is a proper way to show a break, because when you draw a pipe, you don't need to draw the whole thing. You just need to draw the end of it and the end of it, and if there's a feature over here, you draw that much, but then you can leave out a bunch of it and just shorten it up so it doesn't take up a big chunk of a piece of paper just for this long object that's the same. So what we can do is we can cut it out, and then we can do a broken dimension. That's not what it's called, but anyway. But you can do a dimension where it actually has the break line on it, showing you that it's really longer than you're showing. Okay. But anyway, that's an S break, or a conventional break, and there's a couple of different ways you can do it with solid or pipe type round objects, and I will probably end up making a video that covers that. All right, and that's the end of the assignments. All right, so I've taken 16 minutes to go over all that, so maybe I need to shorten this up. I don't know. So the next thing we'll do is let's go over here to our PowerPoint, and let's just say that I didn't start at the beginning like I was supposed to. Hey, there we go. All right, so chapter 12. Sections, revolutions, and conventional breaks. Aren't we excited? Okay, so basically the whole idea of this video is to help you to better understand sectioning and be able to give me, who's going to be checking your drawings, or whoever is doing the class checking your drawings, what we're looking for as far as assignments, and to teach you stuff that you're going to use out in the real world. So proper cutting plane line representation, sectional views including full, half, aligned, broken out, auxiliary, revolved, and removed sections. Identify features that should remain unsectioned in a sectional view. And you're like, what? It'll make sense, promise. Prepare drawings with conventional revolutions and conventional breaks. The conventional breaks, what I was talking about with the pipe. Modify standard sectioning techniques as applied to specific situations. As usual, there's always exceptions to a rule where you can make adjustments. Kind of like that pipe or that flange, where I'm wanting you to make an alternate view over here using a viewing line instead of a cutting line, even though they're basically the same thing. Make sectional drawings from given engineer sketches and actual industrial layouts. Well, that's what the assignments are going to do. So sectional views are created by, it's like if you went over to a saw and you cut into a part and you were looking at the inside of the part, like you physically cut it. It's going to describe the interior portions of an object, expose hidden lines that you cannot dimension to so that you can see them, and as you can see right here, dimension to them. Because number one rule in dimensioning, I would go with number one rule. Avoid. Do not. Don't pass go. Don't collect $200. Do not dimension hidden features. That includes holes. Sure, you're dimensioned to the center line, but still, it's a hidden feature. Don't do it. You'll get marked off every time. Okay, so there are ASME standards that go along with sectioning. You've got the 14.3 and the 14.2. Multi and sectional views, and then line conventions and lettering. Those are the two areas that are concerned with this. Okay, so cutting plane lines. A cutting plane line is what we use to show how we're cutting the object, and this gives you a really good understanding of what we're doing. You've got this area, this little pocket that you can't see with solid lines, so I can't dimension to it. And it's not really a counterbore, it's not a countersink, anything like that I could put on a note for the hole, at least not this part, okay? So I need to have this section. So what we did is we did a full section. They cut it all the way across. Notice that the arrows are pointing away from it. I'm going to make a video on how to make the arrows correctly, or how I do it in AutoCAD, and you can go from there. Like I said, a lot of the examples they show are set up vertically, but I would like to be horizontal so that, you know, and I really didn't want to rotate this picture and mess up the lettering. So, but, you know, I would run my views, you know, left to right. Now they did a top view, which is fine. I would have done a side view and put my line this way because it's a fairly symmetrical part, even though it's square. All right. So you've got two options. You can either use a thick hidden line, which is just a bunch of dashes, or you can use the phantom line, which is long, short, short, long, and you keep, you know, keep that pattern. And then you have arrowheads, and typically the arrowheads are larger than the ones that you're going to use for your dimensioning. Let's just say that typically it's about 2 times bigger. I don't really have a good standard for that. I'd have to go back and look. But over the years, that's the way I was taught, and what it would come down to is whatever the standard is for the company you're working for. And then again, you also have things like, you know, you have SolidWorks, you have Inventor, those kinds of programs where they've already got that programmed in, and it should make it thicker and, you know, apparent that it's a cutting plane or viewing plane line. All right, and it's going to show the direction you're cutting, and your view that you show is always, well, let's just put it this way. The arrows always point away from the view of the section that you're going to make. So your section view is always on the opposite direction of the arrows. All right, arrows point away from the section view. There, beat that dead horse. So something to remember, we've talked about lines and precedents. So cutting plane lines, they cover center lines, because remember, the center line is kind of the low man on the totem pole, kind of the forgotten line. So you may need to delete a center line or readjust it for a center mark, so that you don't have these lines overlapping and it looks funny and you can't tell that it's a cutting plane line. So an obvious cutting plane shows only the ends of the cutting plane line, or you have no cutting plane line, which is really weird, but you can do that. But I don't, in the things we're going to do, I want you to draw one so that you get in the habit of understanding what a viewing plane, cutting plane line looks like. And then you're going to show the cutting plane line if in doubt. Well, that's my default right there. You show it, that way I know if it's a half, offset, or whatever it is. I want to know where I'm cutting through. Now obviously if it's a full section of a round part, that's pretty simple to figure out if it's, you know, full or half. Alright, moving along, we have some pictures, and this is what they're talking about. So you can also make, typically this is what we call a viewing plane line, but like I said, a cutting plane line, there's actually 3 variations. You've got the phantom version, you've got the hidden version, and then you have this little L version where I don't have anything in between these 2 lines. So, you know, you can make this and then mirror it down, and you've got the other side, and that's technically a cutting plane / viewing plane line. So here's an example of where they didn't put one in. I would still do it just because it's a good habit to get into. And it definitely emphatically says, hey, I've got this done. That's what it is. This is a section. All right. And here's an example of where we have a removed section showing the section down here, and it's listed to see AA, BB. So here's AA and BB. On a regular section, you don't have to label it that way if you don't want to. Some people do. They'll do a half section or a full section, and they'll label it that way. And then under the view over here, you know, the side view, they'll put, you know, section AA. If it's on another sheet, that's how you have to do it. And this covers that here in a minute. So when you're talking about identifying the sections, especially if they're removed or on another sheet, we're going to start out with AA, and letters that you avoid are I, obviously, because it looks like a 1, O, because it looks like a 0, Q, close enough, S, I guess because it looks like an 8, I'm not sure, X, and Z. Not exactly sure why it would matter on those either, but hey, I didn't make this PowerPoint. I just adjusted it. So anyway, you can use double letters, like it could be AA, AA if you had to. I'm not exactly sure why you would have that many sections, but hey, you never know. So moving along, poor sectioning practices. Okay, so here are things not to do. Do not take a section from a section. Don't project off of a section view. Always, and this is what happens in SolidWorks and Inventor. And I get more SolidWorks drawings because I teach a class just in that. But I'll have people that will make their 3 views and then they'll make a section view over here. No, you delete or don't create this side view and you go tell it to make a section view, and that replaces where your side view would actually be. That is the correct practice. So we don't take a section from a section. You have to take a section from an actual solid view, and we don't project any other views off of a section view because it is a, it's a special view in itself. So if you can keep that straight, we'll be in good shape. Yeah, exactly. So, all right. So section lines. They're typically at some kind of variation of 15 degrees. They're not going to be horizontal. They're not going to be vertical. You want to try to keep them from being parallel or perpendicular to the lines of your view. They should be equally spaced. A typical setting, which is shown here, is a 16th or 1.5 millimeters. Honestly, you just need to have enough of them so that it looks, and you'll figure it out. I'll give you an idea. I've got an example drawing to show you that kind of shows that. All right. On an assembly drawing, which you'll see here in a minute, you want to change directions of your views. Of your section lines. And you're going to omit text when necessary to have omit around text when necessary to have text. In other words, the text is going to wash out where the section lines are, or you'll put a little, blackout there, or what we call a wipeout in AutoCAD. And what that does is the text it'll have a space around it so that it's easier for you to read the text. If you have to have text inside on labeling a view for some reason, I'm not sure that you would. Architectural drawings you might, but anyway. Okay, moving along. So here's an outline section lining. In the old days, when we didn't have CAD, we got lazy and we sped things up by just doing a little bit of our hatch pattern, or sectioning. I never did. I always drew all of them, but that's just because that's how I was taught. But this is just an example of outline section lining. You're going to fill in the whole thing because you're just going to use the hatch command. It's pretty simple. Now, there are patterns for different materials. You're going to find that out in, I don't remember which class it's in, but in one of the classes you go through and you talk about the different kind of materials. I think it may be in 102. Yeah, it is. It's in 102. And we talked about some of the different materials and the different hatch patterns that they have for doing sections. Okay? I'm not going to make a big deal out of you picking the exact correct hatch pattern. My main goal is that if you're drawing something that is an assembly drawing, make sure that the parts where they intersect, they come together, they're going to have hatch patterns that are at different angles. You might even use different hatch patterns just to break it up so that you can tell which part is which. That's how it works on an assembly drawing. You'll also notice that bolts and shafts, washers, I believe that's a washer or a gasket in there, those aren't shown sections. It's just a thing that we do. It helps to break things up so that you don't have too much information and have a really busy drawing. Okay? That's mostly what it is. Basically, like I was saying, things that are really thin, like a gasket or a washer, you're not going to section those either. Or they can be drawn without section lines. All right, so full section. Here we go. A full section is where you cut all the way across, like so. Notice the arrows are pointing away from my section view. Like I said, I would like things to be horizontal when you draw them, okay? That way it looks better on the sheet, whatever sheet size that you pick. A half section, you're going to take a quarter of it. Instead of slicing all the way through it, you're going to slice halfway through it, right? And you're going to remove a quarter of the information out there. And it's used to show this here. And like I said earlier, you could say that you could have a dimension from here over to here that tells how far in they need to go from this point here. So they would zero their tool on this diameter and then add whatever that distance. I can see that. I could also see if you did a full section and you gave them that full diameter that they would be a little happier. So sometimes a quarter sec or a half section really doesn't help as much as we might have been led to believe. How about that? But here's the idea. Now, I've always been taught that you have the arrow pointing this way. This is showing the direction of it. But there's usually, or at least what I was taught, we always had an arrow pointed down here. You can go either way. Like if you just put this one, this is showing that I'm looking this direction, that's fine. But you could also have one going down. And that's just what I was taught. And that may be like the old standard, and this is the new standard. I don't know. I'd have to look in SolidWorks to see what it does, because they usually have the standards pretty close, or pretty updated in there. All right, so that's a half section. Now this one kind of confuses people sometimes, where you're doing an offset, and basically what I'm doing is up here I'm showing the path. Notice that I go all the way through the feature that I want to show, and then I move up or forward, up or back, whichever, and then go through the center of the next feature and over. And I try to do it kind of in between the features, before I move up or down or left or right, whichever direction you're at. And see, now this kind of drawing here, this kind of part, you could get away with doing a top and a front view here. That would be okay, because it's not a really long part or really big part that it actually takes up a lot of space, and you could dimension it and it would make a nice pretty drawing. Okay, this example over here, what they've done is it's on an arc basically, but they've done their they're showing that they're still looking this way, and what they've done is this kind of rotated up to here, if you will, to get that alignment, to show that how that is doing its thing. So basically they're running along this center line or this hidden line, and then they come down and they go over, but when they show it, they're basically rotating this over to where it's parallel with this viewing plane line. Okay, you don't have to do anything like that one, so it won't be too confusing for you. Hopefully yours is more like this. All right, now I rotated this because I wanted you to have a better idea of the fact that I need things sideways. Okay, I need them horizontal. You know, I need them landscape. Basically, they had this down on the bottom and this was on top, and I was like, no. But the idea is still the same. This is what we call an aligned section. An aligned section means that I have this symmetrical part, but I want to make it look like I did a full section of it. I don't want to draw it where I see this, you know, rotated down here, because technically that's not true shape and size. It's not a true position of it because it's over here. It's not lined up with, whoops, it's not lined up with my axis right here. Okay, so when I do an aligned section, a lot of times you're going this direction and then rotating it here, but it doesn't really matter. The whole point of it is I'm facing away from, my arrows point away from my section view, and I just take this and I'll line it up, or align it, if you will, so that it looks like this right here. So hopefully that isn't too confusing for you. All right, so here are some things that you do not have to section: bolts, nuts, rivets, screws, rods, shafts, ribs, I'll show you why here in a minute, webs, spokes, bearings, gear teeth, pins, and keys. And you're going, oh, whoa, wait a minute. We're doing a wheel and it's got a spoke. Well, we have to see what the cross-section of that spoke is. And we're using a revolved section to do that, which we'll move along to here in a minute. So in general, spokes, you don't have to. You don't show them in like a full section, I guess is what you want to say. They can be, though. You can do a revolve section if you need to see the cross section of that piece. Here's some more examples that are shown vertically, and basically what they're doing is, I don't know why they have 3 views. I guess they're just wanting to show you what it looks like. So they did this view and then they did this view. I mean, technically you really only need 2 views. You do the section view and this view, and then, you know, that would be rotated up here and it'd be over here. So I'm a little confused as to why that even matters. And this example, they don't even have this view right, so I'm not exactly certain what the deal is. It should have looked more like that. I don't understand how sometimes when these people do these, you know, examples. Anywho, intersections in section. Basically what they're trying to show you is what does a hole look like in a section, or where something meets in a section. And I'm not quite sure what the difference, this right here, why it's any different, but anyway, you know, they're just showing you how it cuts into the part and how it would look. And I'll be honest with you, I'm not sure that that's, oh, well, yeah, as you go away from the center of the part, yeah, this would move, this line would move down some. Anyway, so yeah, so just be aware that, remember when you project stuff, to just think about it. Made me think about it, so there you go. All right, so conventional revolutions. And you're like, what? We talked about this. We said webs, or let's see, it's a web, it's a, here, let's back up. What did it say that you don't section? spokes, webs, and ribs. Okay, so think of this as a web. This is a spoke, right? Sometimes these might be considered ribs, but it's a web. So when I draw this, I rotate this down and align it, but I don't section it. I'm going to section this part. I don't know why they didn't show this sectioned like they should have, you know, but they didn't. But basically, when I draw the view, I don't want to draw it like this. I want to draw it like this because it doesn't look weird. And this is true shape and size. It's not foreshortened. This is foreshortened, which is not a good practice. Okay? Seeing things not the right shape and size is really not an appropriate way to show your parts when you're trying to throw dimensions on there and so on. Alright, so here's our spoke, same idea, like this. Now if I needed to do a cross section of one of these, I could do that, but I'm still not going to section the rest of it. Okay, so that's kind of the difference in what we're talking about here. Alright, so that's a conventional revolution. Now this is the one where they had a completely horribly wrong example. So I went and found some better ones. This is an example of a broken out section. So you take a short break line and you just draw that in, and then you just hatch the areas that you need to show. So basically I just need to break this out so that if there wasn't another view where I could dimension this hole, I can dimension it here. I can at least locate it, right? Because this kind of a part, I'd basically do this view and a top view and I'd be done. Well, I can't dimension this hole without doing like a side view that is really not necessary unless I did a partial view. So I can just do a broken out view, and then I can use a leader to dimension, you know, to label what the hole is, whether it's threaded or not. And then I can have a dimension from the top down or the bottom up, whichever my datum plane that I'm using. See, you need to remember datum planes. Where am I dimensioning from? You need to think about that and dimension from the same ones on each view. You know, if you're going to draw, you know, if you're going to dimension from the bottom and the left side and the front, then those are the planes that you need to dimension from in each of your views. So in this case, let's say I was going from the bottom, I'd have a dimension from here up to the center of that, located on this side over here, and then I would have a note with a leader showing, hey, this is how big it is. Now, in this kind of view, they don't get rid of the hidden lines. In a regular view, like a half section, I didn't mention this earlier, but you actually get rid of all hidden lines in a section view. However, if it's a broken out section, you leave the hidden lines in because you need them, and you just make solid the places where you cut. Okay, so it's like I took a hammer and I knocked a corner out of this and I can see the material. That's basically what it is. This one's the same idea. They want to show this undercut, and again, on dimensioning, I'm kind of baffled why you wouldn't want to have this fully shown here. You know, break it all the way down so that I could see this and dimension both this and get a diameter on it. But again, you could take the dimension here and do that. It would also be possible, I don't know that it's actually wrong, that you had a leader and pointed to it and said, hey, it's this diameter. It's just an alternate way of thinking about dimensioning. But, you know, I think about those things trying to think, that doesn't make sense. But, you know, I remember doing it and being taught that, and I'm like, but if I was a machinist, I want to know what this diameter is, and I want to know what this diameter is. Because this is like a reverse counterbore. But this is showing me what it looks like on the inside, and that's good to go. And I have my short break line right here. And then I have the side view, and see, this is aligned or lined up the way that I want to see it. I want to see things lined up horizontally as much as possible. Okay. All right, moving along. Auxiliary sections. Now, that pipe flange, the flanged pipe, you know, the arced flanged pipe fitting, that would actually have an auxiliary view. Not an auxiliary section, but an auxiliary view. But the way I explained it earlier is I want us to do a removed view and stick it, or an alternate view, and stick it over here, and we're going to put our viewing plane line up there lined up with that flange. And if I have to do a special video to show you how to do that, you know what? I will. I'm trying to make things better and easier so that you guys understand this stuff. And I apologize, we got a 45-minute video out of this, but it is what it is. Sometimes lectures just take a long time. Okay, so this is auxiliary section, and basically what it is it's not parallel to any of my other drawing planes. So I go at the angle, and then my view is parallel with my viewing plane line or cutting plane line. Okay, and the same thing down here. However, on this one, we moved or did a remove section and stuck it over here out of the way. And then they did a partial view down here just to show this area, and that way they could locate and dimension this countersunk hole right there. All right, so that's example of and we're going to do auxiliary views later on in this class. So conventional breaks. So basically what we're doing is shortening up something. If it's a solid, like a square tubing, not tubing, but square, well, it could be tubing. If it's something squared off, then you can just do a broken short break line and you're done, right? Or this jagged thing that looks like I broke it. That's not the greatest. This is better. Another option is to do what we call a conventional break. And that's what this is. And like I said, there should be an example of how to do it in the book. And if that doesn't really make any sense, then I'll make a video and add to it, because I want you to figure out how to do this. I'll even try to figure out how to do it in SolidWorks so that, you know, something easy you can figure out how to do. They should have stuff like this in there because, you know, they need to cover all different areas, you know, of views. Anyway, so basically you've got 1/3 of the radius is what this distance is. And I forgot what the actual radius is of this. I don't think the centers are located right there, but anyway. Then you also have your long break lines for when you have a part that's really, really long and you want to use that. But typically, we're going to do these short break lines on a lot of our machine parts. All right, now, revolved section. I mentioned something about a revolved section. Whoops, sorry, got carried away with the mouse. Revolved section is where you've got a spoke or a bar or a beam or something that you want to do a cross section of, and you can either do it like this where you do a broken out, you know, do your short break line and get rid of the material and just show the cross section of that piece, or you can do it right on the part like that. Either way is legal. Typically you would have a center line on it, just to kind of show that you kind of rotated it on that center line 90 degrees so I could see what it looks like. And that's just another handy way of showing those kinds of views, you know, that kind of, you know, geometry to see what it is, and you can dimension off of it as well. And if you have it open like this, it makes it easier to dimension. So extrusions, spokes, beams, arms, those are all things that we can do revolved sections of. We don't do a full section of them, as I mentioned earlier, but we can do a revolved section. Okay, remove sections. You're going to have a drawing where you got 2 or 3 removed sections. You're going to do like a left side, or I'm sorry, a right side and a left side view. And then you're going to have some sections in here that you're going to, hey, I have an AA. Here's section AA. I've got section BB, and put section BB down here, and so on. All right, reference arrow method for sectional view. Okay, I don't like this. I think this looks really goofy. I'm not exactly sure what standard uses it, but you might run into it, so there it is. I want you to do it the other way we've been doing, and I kind of showed you. All right, locating sectional views on different sheets. Now, it's very important that you label your sections, especially if you're going to do this, okay? It's just what you do. So if it's on this sheet here is your view with your section line, your cutting plane line, then your section's on a different sheet, sheet 2, zone B3. Now we've talked about zoning, and this is a use of it, where you've got it labeled like A, B, C, D, E, F, G, running up vertically, and then horizontally you have 1, 2, 3, 4, 5, 6, 7. Okay, in AutoCAD I don't have you set up your paper that way. But in SolidWorks and Inventor, at least in Inventor, I'm pretty sure that it's set up as zones. And both of them may be. I'm not exactly sure. All right. Trying to think what else. So anyway, that's just locating them on different sheets, and that is the end of that. Okay. So we went over the assignments a little bit, and maybe I need to redo this and do that last. I don't know. What I did want to do is I wanted to show you what I'm expecting. Here is my template that I made, that I used as an example for creating your template for different classes. And this is a half section. So let me go over here to model space, and so I figured out what size it needed to go on the viewport first. So I drew up my drawing like so. Before I did any dimensioning, I went over here and said, okay, I double clicked in here, I did a zoom all, and it did that. And then I went here and I said, hey, let's see what 1:1 looks like. Ooh, that's tiny. Oh my, that's awful. Then I went, here's 2:1. Aha. There we go. Now you'll notice I used annotative dimensioning. I also used annotative text. And since it's an inch drawing, I used annotative, just the regular one, and it's set up correctly. So I'm going to deactivate my viewport by either hitting model or double clicking out here. And if I go back to model, so what I would do is, the first thing I would do is draw them apart, scale it on the viewport, right? Then go back, go to the correct layer, hopefully you think about it. Or if you go over here to annotate, then you can tell it that you want to use dimension as your dimensioning layer, because that's what I have set up, and mine's red. And then I went in and I dimensioned all this. Now, I had to set up these bilateral, or not bilateral. Well, anyway, I had to set up tolerancing. In CAD 200, you learn how to do this. Well, basically, on here, things that you have to do is you have to go in and you have to set things up under, it's like if I pick this, right click and go to properties, and I go down here to tolerancing. So this is set up as a deviation, which means it's plus, it has an upper limit and a lower limit, okay? Now, let me hit escape, and I'll pick this one. This one is set up as limits. It's set for 0.7500 and then 0.7505. They had it flipped for some reason, but the way AutoCAD does it is it puts the lower limit on the bottom and the upper limit on the top. Logic, hello. But it's not plus or minus. This is actual limit. It gives you the actual limits. So that's limits. This is deviation. You know, how much does it deviate? Plus or minus, whatever. And it's not symmetrical. Okay. Your other options here. Let me just show you. So you have symmetrical. So that would be like plus or minus 0.001. Okay. And it would do that. But if you have it plus 0 minus 0.002 like this is, then you have to use a deviation. So that's the difference on how to make them tolerance. And you don't have to create your own style. All you do is put the information, you know, put the dimension on there like you're supposed to, get out of dimensioning, pick this, right click, go to properties, and then go down to tolerancing and adjust what you need to adjust. And it'll be fine. That's all I did. Mr. Anderson helped me. He did a good job because it's been a while since I had done this, and I can still do it. Now, I'm not a real fan of this right here, but this is standard. I'd have to go back and look it up in the, I've got a book that has all the commands in it. There's a way to tell it not to do that standard, but whatever. So I have 3 times. I had to edit this too and add the 3x in front of it. Okay, so when you do that, when you double click on it and you edit it, you've got to remember that this is, you know, AutoCAD put this in, so you don't want to delete it accidentally. So you need to use your arrow keys to go left until you're in front for sure of the text that's defaulted there, you know, the dimension that you want to keep, and then add whatever it is in front of it. Like, you know, I'm in edit it mode here. You know, if you need a diameter, if you need degrees, you've got diameter, you can add those things in there. Obviously, this is a radius. It doesn't need a diameter. And I used the actual radius command under dimensioning. So up here under dimensioning, I used radius, so it gave me the R. I just needed to put the 3x so that it knew to do that. Now my question is why are there 3 radiuses? That could be an actual error on it too. I found some other ones too, like this here. If you run into any thread notes, hopefully I will have that figured out for you. I try not to give you any with threads on them, like this one. For one reason is he had it wrong. Whoever did this, they didn't have it dimensioned correctly. So anyway, the other reason I wanted to show you this is I wanted you to see what I like, what I'm looking for. Mr. Anderson said, yeah, that's a nice looking drawing. I said, thank you. You know, because I try to get it across to you guys, you know, what I'm looking for. Notice how consistent the spacing is, and he had a good example. So you're trying to figure out how far I need to have, you know, these two apart. Well, since they're a single line, they're not extra like this. If you think about the height of your lettering and leave about that much space in between, and you know, you can use stretch to, you know, I can use stretch, go home, and go stretch, and I can use a crossing window like so. Didn't pick it, did it? Huh, weird. Oh, I'm in the viewport. Haha, funny. Anyway, we'll go over to model space. How about that? All right, now there's 2 ways you can adjust this. You can pick on it, and then it pulls up all the different scales I have. And then you can pick this and you can move it around. Well, if it hooks onto something you don't want it to, then that doesn't help you out. You can also stretch and do this, and then, you know, come out here and pull it down a little bit if you wanted to, like so. Now, one of the reasons that those are showing up is I have the magic triangles on down here. This one you want to have on because it shows annotative objects, and everything we're using is annotated. Text, multi-leader style, dimensioning, okay? Beat that into your brain, please. And then here is your other magic triangle that says show, oh no, I'm sorry, I'm reversed. This is show the object, so that one has to be on. This one shows scale changes. So in other words, when I pick on this, it shows all of them, which if you can look past that, it's okay. Here's how you get around that. Figure out what scale you want to use first before you dimension it, and you'll be good to go. And there's some other things you can do. You can go in, you can edit it, you can delete the extra dimension scales, but why? Why don't we just keep it simple? Okay, so if you have any questions, feel free to contact me and let me know what you think. I'm going to go ahead and post this and get some feedback. And from there, I'll either remake it or leave it as is. So as I always say, take care out there, and we'll see you around. Have a good day.